Hey everybody, Miss Saylor here, and today we're looking at Lesson 4 of Unit 2, which is The Great Discovery. In this lesson, we talked with Madame Dusong, who was studying blood and looking to solve some issues related to the amount of red blood cells. And so we looked at this type of equation first, where we looked at a percentage of our blood that was red blood cells compared to a sample size. And then we were working on dividing that by the volume of one blood cell to look at how many red blood cells were in the body. And so with an equation like this, notice that the top number did not have an exponent. What we did to work with that is that we put it into scientific notation form with a power of 0. Because please remember that the 0 exponent property says anything to the power of 0 is 1. So 2 times 1 does not change our value, but it does set our problem up into the correct notation so that we can use our division properties of exponents. And we divided 2 and 9 to get 0.2 repeating. And when we do 10 to the 0 power minus the 14th power, minus a negative actually turns that to a positive 14. We need to turn that number into proper scientific notation, which is not shown here. So we should actually be moving that decimal point over to make the number 22222 1 power of 10 bigger, 2.22, which would then in turn, sorry about that, balance out the exponents 1 lower. So whenever you are converting a fraction into scientific notation, if I'm moving the decimal point to make the number be bigger, I need to balance that by changing the exact same amount of powers of 10 with the exponent in the opposite direction. Okay, so now we're going to look at adding and subtracting numbers in scientific notation, and we're always keeping in mind that conversion balancing, where if I move by a power of 10 with my coefficient to a bigger amount, I'm going to balance it by the same power of 10 in the opposite. So multiplication and division of powers of 10, even though the work we're doing is adding and subtracting. For all of our addition and subtraction, we do need to have our powers of 10 in the same exponent. It is up to you whether you want to change one of the numbers to be, I would change the smaller power of 10 to be bigger to match the larger power of 10. Your other option is to turn both numbers into standard form, do the addition or subtraction, and then convert them back to scientific. I will show you both ways, and you're going to just choose whichever one makes more sense to you. So in this case, we've got 10 to the power of 5 and 10 to the power of 3. Generally speaking, I want you to think about taking that smaller power, 10 to the third, and increasing it to 10 to the power of 5. So we're going 2 powers of 10 bigger with this number. So we're going to compensate by doing 2 powers of 10 smaller with the coefficient, the 3.2. That puts both of our numbers in the same power of 10. We're going to add our decimals and just keep that power of 10. And when we put it all together, it's already in correct scientific notation, so we're done. If we move these into standard form, we're going to recognize both positive exponents means that these are bigger numbers. We're going to move the decimal points, add them together, and then move it back into that power of 10 or scientific notation, whichever way works for you. In this case, we've got subtraction, and what we also have is one number that's in standard form. We do still need our powers of 10 to be matching, and in this case, it's generally going to be easier to convert both numbers to standard form, because if I were to convert 0.0045 into scientific notation, I generally am not going to be converting it into the same power of 10 as the other problem, so I just have an extra step. But we'll show both ways anyways. All right, so if we convert to standard form, this number is already there. I've got power to 10 to the negative 4, which is going to be a smaller number. Move that decimal, do my subtraction. Sorry, you're missing some of these numbers here, but you can see the number is a very small number, and then we're going to convert that back into power of 10. which in this case, I'm moving the decimal point 1, 2, 3 powers to the right. So the numbers are blocking out weird, but that's 10 to the power of negative 3. If we convert into scientific notation, we've got to move it to correct scientific notation, and then we're going to convert them to be the same one. So negative 3 is actually the larger exponent power because in negatives, it's opposite. So I'm going to change the other one, do my subtraction, and in this case, it's already in scientific notation. So whichever way works for you, just take the ones that is best. All right, part 2 is coming up shortly, so see you in a sec.